In the last video, we completed the video counters, video sync, borders, and flip screen sections. Today we'll work on the paddles. This section has some analog stuff we can't put in this FPGA, so we're going to add the 555 to our breadboard, put out the pad enable line, and bring in the timer's output. We'll actually add two 555s, one for each paddle, and select the proper signal based on the player 2 conditional line. We can drive the pad enable line directly from the FPGA, but we'll need to level shift both 555 outputs with 74 LVC 244 gates. Since we won't need the 4016, we'll need to bump those series resistors to compensate for the analog switch drop. These other three gates generating the P2 conditional line will be generated in our configuration module. Note that player 2 condition is only applicable when player 2 is up on a cocktail table model, so you can skip that second 555 and associated passives if you're only using this in upright mode. You can check out part 7 for more details of how this section works. For the rest of this circuit, inbound we have BTB hit, serve wait, VSync, attract, and a bunch of video signals. BTB hit drops when the ball hits the back wall, making a small paddle. We've also got our two paddle lines, and we need P2 conditional for the selector. She puts out pad enable, pad, PC, and PD. PC and PD will be used later in the ball motion controls for determining the paddle hit deflection angle. I redrew the timer circuits, so let's add this to the breadboard. We'll need those 555s, two sets of passives, and we'll consume two 74 LVC 244 gates. I'm using an old prototyping control board for the pots. It's got pretty much everything except for AV jacks. Alright, back to main and add the 3 required ports. We need to add them to PCF as well. This section has a bunch of gates, a 4-bit binary counter, and a flip latch. I'll start a new file for more complex gates, and we'll add a few flip-flops. The ICE40 registers have a limitation in that they only have one reset input, so we can't define a complete 7474 gate in a simple way. This one only uses the reset side, so the definition here is easy. If you only need the set, the compiler achieves this simply by inverting data in and reversing the outputs. I made 3 simple flip latches, one with just a clock, one with a reset, and one with a set. If you need both set and reset, that becomes a bit more tricky, and we'll work on that later. Create a new file for the paddle section and add the parameters. Interesting that the vertical lines are all primes and the horizontal lines are all UI signals. I would have expected that pad enable is derived from UI signals because it is a UI element, but go figure. Next, add that reset type latch. and add a 74-161. Before doing the rest of the output, let's create the paddle enable line. I was able to just use VSync for this whole chain on our minimalist prototype in part 27. Next, we need to make a mux to pick the paddle. This is not complex enough to make a separate mux gate. And finally, we can complete the pad output. Save that. Back to main, instantiate that section, and wire it up. We have two outputs, but we only need to create a loose wire for pad. Paddle enable is hooked directly to main's I/O port. Oh yeah, I need to hook the pad line to the video sync section. We already have a test button hooked to player 2 conditional from the previous video. That will select the proper paddle. We just need another test line for attract mode. Save that. Compile. And turn it on. Attract is on, so we have the full paddle. Flip that. Looks fine. Turn off attract mode. And we have paddle 1 working properly. Always amazing to see that done in hardware. Flip the screen and paddle 2 is working. Alright, great. Moving along. Here's a comparison to the breadboard in the same build state. In the next video, we'll do the ball XY counters and motion controls. Thanks for watching.